Okay, so in terms of context for you, Jeff, uh, it's difficult to know where to start, but basically we've got a very modular architecture. I'd recommend you take a look at the OCP HPC wiki. And if you see there, you should be able to see a presentation I gave at the OCP Global Summit last October, where I gave a very high-level overview of what we're up to. So we're creating effectively like an OAM module or NVIDIA's SXM module. But what we're doing is we're saying we've actually got rid of the motherboard. And so these modules have backplanes on them where media can be plugged in or cables for connecting these modules together. So that's the sort of the high level principle of what we're doing. And these modules are, as much as anything, they're basically, we've re-architected it from a first principles approach of we need to get significant power in and significant thermal and energy out of these modules. So the module's designed around that. But it's extremely, it's very flexible and composable to any domain-specific architecture needs. And so, you start with a module. Every module ideally can self-boot, so it can come up and be ready to roll and could run standalone. But obviously, these modules are all going to be connected together. Every module can have up to 16 media modules plugged in. The E3.S format is what we're supporting. And so they would be they would be managed by that module. And so what we've got is a system management aspect of that is we want to have a standalone system management. We'd like to modernize it and try and drop all the legacy of the 1970s that still seems to be hanging around in system management with I2C and in the rest of it. But look forward. We want to leverage, obviously, all the good stuff that's been going on, which you guys have all been working on in the OpenBMC, the Redfish. And then, by the way, I'm not an expert in this area at all. But we want to leverage all of that, but we want to recognize that this is a very composable architecture. And therefore, we need some higher level system management aspects that allow us to discover and bring up a machine gracefully where it can be wired up in many different ways and maybe even miswired, so that the system management is aware of any miswirings and can deal with that before turning a machine on. So I guess in terms of this particular work stream, I think that there was a conversation between John Lung here and Alex Level-Troy from Los Alamos National Labs on the high level stuff. And I thought it was a great discussion. And basically, I think John educated Alex on some of the higher level stuff that you guys are already doing. I'm aware of the CMS, the CXL, discovery of the CXL memory fabric, the memory resources, all of the good work that's going on there. So I'm not sure if that really covers everything we possibly need to do here, but essentially that's what we're up to. Obviously security. These modules, when you put all these modules together, many hundreds or thousands of them, and depending on a big supercomputer, we want some level of root of trust at the beginning. So whether we can declare one node is a primary node that then discovers everybody else, or we have a separate DCSCM type node that gets everybody up and running and coordinates all the system management is another area. So The only other piece, well, the main piece that we're doing is how do we do the hardware? So that was where really where Munir is coming in from Lattice Semi is there's are you familiar with Libra BMC, the hardware, the open hardware aspect of the BMC? Jeff?
I'm not.
And John, out of interest, were you familiar with it before or not?
I've heard about it, but I haven't really looked into it at all.
Yeah.
But yeah, my understanding is that it takes a FPGA and puts a load on it to make it a BMC.
Yeah, the idea is everything's completely open, even the hardware down to the RTL level. So instead of taking these off-the-shelf BMC processors like A-Speed, etc., you actually start with a blank FPGA, and even the hardware is open source from the ground up for security reasons.
Yep.
And I guess IBM were the ones that started pushing this, and Xilinx it's done in OCP, and the DCSCM I think has been built with a Xilinx FPGA and a Lattice FPGA. Correct, Munir? Can you put any more background on
I think if
GMC?
I can help out a little bit, Alan. So from the BMC perspective, right? I think we say it's a zero trust because if you look at existing BMC solutions, there is multiple problems that industries we are seeing, right? Obviously, security, as Alan mentioned, BMC itself is a very highly privileged component system, right? It has access to all memories, passwords, all those things. It can do updates, whatever it likes to, right? So obviously, security is a big risk, and I think if you look at A-Speed, it's basically a black box, right? You have almost about a few hundred megabytes of stuff. There might, the U-boot and few things that typically the hyperscalers or data centers, they don't know exactly how they're doing it. So there's initiatives going on called Zero Trust, which is basically everything is open. As a customer, you put what you want to do, which is what the Zero Trust is coming from. But even after that, I think one of the choices for FPGA that we see is if you look at legacy ASP BMC, they have so many interfaces. There's a legacy interfaces that people may or may not use, especially for hyperscalers. Sometimes they don't use a USB interface. Sometimes they don't need a display port, things like that nature. And then what happens if you have those unnecessary interfaces? Then obviously you have to, those are the holes that hacker can come in, right? So you have to also test those unnecessary interfaces. You have to have some way to protect those things or actually close those things, and that's not very easy to do. So that's what we are seeing. The FPGA acceptance and Libra BMC, one of the one that is, everything is open, as Alan is saying, to the RTL level. And from the development perspective, there is a motherboard that IBM designed that has FPGA as a BMC, and especially the CP5, Lattice CP5 BMC that is already out there, done by ODM. We also showed in this, OCPs, the full functional BMC with an ECP5, right? Well, what I mean by full functional is there's few functions missing still, but I think that's what we're seeing, that one. And that's the whole industry is looking at, a flexibility approach on the BMC itself, rather than having like what you have a black box BMC.
Hey, thanks, Munir. By the way, Munir, you might want to check into your new headset. I've got a funny feeling you sound a little bit muffled. I think the noise cancelling feature of it might not be very good.
Yeah, it's possible to change those. If it's a new headset, I'm still figuring out, experimenting, but yeah, I'll work on that.
Yeah. I mean, we can make you out, but it just seems like there's some quality issues in it. Okay, so what I wanted to really get into today was we're trying to pull this DOE proposal together, right? So, and we have this system management aspect. So this is a New Frontiers funding that's coming out of Oak Ridge National Labs, and I still haven't seen the final RFP, it just struck me last night that I probably need to maybe just go back to their direct website and see if it's there. I assumed I would get a notification with email because I'm in active correspondence with them, and I did ask them, and they said it was with the procurement department. So, but we've got 4 to 6 weeks from when that is when the final RFP is released to get a response back into them. So hopefully the clock hasn't started without us knowing, but I will double check on that. So let me just share my screen. Just bring this in. Where's the share screen button gone? That's strange. Well, there it is. Okay, can you see that? Yep. Okay, so this is what I wanted to cover today. So really adding a section in the proposal that explores the plausibility. Oh, sorry, hang on a minute. That's a thermal management one. Apologies. System management. Okay, the system management one. So really just the two sections, the system management hardware section, documenting the hardware aspects that need to be designed. And I think I'd like to try and get down to in the proposal a sort of a hardware block diagram level where we're describing all of the interfaces as we see them. So that's really what I want to get done in the hardware piece. And I guess, Munir, that's really been driven from your end. And on the software section, it was really, I've got here detail what can be leveraged from the existing efforts, what you guys are all up to, John and Jeff, and what additional things we need to be done to enable the highly modular architecture of the HPCM-based system. So I've given a link in that email that is sent out to the actual document. I can flash up the document, but there's nothing in there from the system management perspective at the moment. I've just pulled up this presentation here. It was the inaugural meeting slides, and this was as much as anything for Jeff's benefit, and maybe to discuss the hardware again. This is the basic hardware block diagram that I'd like to put more meat on. But basically, this is the device that you're proposing, right, Munir, the Lattice Avant E1319 by 19. And I believe that would be a little chiplet device which would have other components on it, like security puff components and maybe some flash, etc., right?
Yeah, so it will have definitely the security, right? Compliant with the NIST compliance about the security, but we're not saying it's the MCM or not, but yeah, it will have security.
Okay, so the first thing is that's the device. Then we've got, these are the 16 E3.S interconnects or 16 EDSFF interconnects. We have some 4Cs, so we could support a NIC 3.0 potentially as well. And we have all of the each one of these connectors has a bunch of sideband signals, I2C and static signals, etc. And so we have that. So what we're using here is these are tiny little FPGAs where we can aggregate all those sideband signals into a single wire sideband aggregator, so that we can bring a single wire across from all of these connectors into this main Lattice FPGA. Likewise, we would have another ICE that would maybe work on the power sequencing and monitoring circuits, capture all of those, and bring that in over a single wire aggregator as well. And then we've got these topology interconnects. So we've got 8 of these. These are the ones that connect all the modules together. So they're module to module, and we wanted to move towards instead of putting a bunch of sidebands on here, we want this to be a universal interconnect. So you could put Ethernet over here, or you could put PCIe CXL, or you could put NVLink from NVIDIA or Infinity Fabric from AMD, etc. So it could be any protocol, any speed over here. So obviously we know that Ethernet, you don't have any sidebands at all on cables. Whereas PCIe, you have all of the sidebands carried along, right? So what we wanted to really do there was simplify this to our own, because it's just between these modules. We would maybe use LTPI or some variant of LTPI to really get the sideband communication, out-of-band communication between the modules up and running. I don't show here
A quick question, right? So BMC is also communicating to the management for those modules, right? There's 8 modules. What is the interfaces you're thinking? Is it LTPI you're thinking? I'm not sure I get that.
On these connections here, sorry.
Right. What are these connections?
Yeah, so I was thinking it would be LTPI, but I guess we may need some sort of superset based on conversations with yourself. This may need to be.
At the end of the day, you need the BMC to be the remote manager, right?
Right.
So that means you need to have some kind of connection that is better than LTPI to remotely manage, update, push the operating system or push the, any application to those, 8 modules, right? So I think you need something, more than like the Ethernet or PCIe connections there.
Right. Okay. So maybe what we need to think about is what is the master or the host module that manages everything and connects back to the so that's an important aspect actually, that we've got hundreds or thousands of these modules, each with this circuit. They can all boot up by themselves, but how do they get communicated back to what is there?
Yeah, you need to have some way to connect to a remote administrator for all those,
Right. So there is a control plane that I wanted to add to this that could actually make these orange LTPI ones redundant. I.e., it's a case of I'm not too big a fan of okay, well, basically we're connecting everything together through these fabric cables, and this is giving us our system management. Personally, I'd rather a clean system management where you have a dedicated control plane network. And if that was in some sort of, and because these modules are connected together like in a mesh form.
My question is, Alan, let's assume that I'm a system administrator, right? I have one of the systems that has 8 modules, and I want to push a new operating system. How do I do that without me giving an access to the BMC?
Yeah, so if you got what you're saying is, do we need an additional management port over and above these?
We have to have a management port because what happens, when you try to do any kind of operating system update, for example, right? You want to, typically what is done today, and we can definitely think something different, but what is done today is the BMC goes and changes the BIOS and says, you know what, next time you boot up from this particular either virtual DVD or virtual USB or something, right? And the BMC shuts down the server and then turn it on the servers, but the BMC already put that information, that operating system or something, it could be a few hundred gigabytes in some place. And then when the system boots up, it sees that virtual USB or virtual DVD or whatever, or the virtual media, and it boots up from there, right? So BMC needs to have an access to update the operating system, OS, application, anything to those 8 modules. So we need to have some kind of, some kind of high-speed port there, right? At least, which is what typically we have. BMC has a, management port, which also used for, some of the file transfer.
Yeah, okay. So either we would need an additional port, which, okay, fair enough. So these little green arrows are representing the new piece where we're thinking that we would put a control plane between all of these system management devices. So in the minimum case, there would be 4 of them. And what we're talking about is in the module, we'd actually, because the modules are all next to each other, we'd have a free space optical communication link. So there wouldn't actually be a physical connector. So I'm just thinking that could be an entry point for your system management interface would come in over that control plane. So the system management interface would simply talk to one of these modules, and then it would filter through to all of the other modules to manage everybody through the control plane network, as opposed to having it would be a nightmare to have a separate dedicated management port on every single one of 1,000 or 10,000 modules. So you want a control plane network, and that's what this optical I/O piece here is the control plane I wanted to add. And I think that would be where so somehow you'd have a coupler for a system management interface to enter into this control plane network.
Your thought is this control plane network is basically going to interact with 8 modules, right?
Yes. Well, you say 8 modules. You keep so you're referring to like 8 modules in an OAI chassis, but I'm referring to hundreds of modules or thousands of modules in the wall of compute where you've got these modules all on a big wall, right?
Okay. And then how do you plan to give the access to from outside world?
How do you plan to give access? Sorry.
If I'm the administrator of the system, right, or the clusters or the data centers, right?
Right.
How do I log into this particular? Let's assume that they have 8 modules in a chassis, just to make it simple, right?
Right.
Or in a board, 8 modules on a board. How do you plan to give that access to that 8th module to an outside guy who's the system administrator?
Well, I'm assuming you would dock in with whatever it was. If somebody was there with a laptop, or if it was connected into a regular management server somewhere, then there would be a cable coming along, and it would come into this control plane network, right?
Well, typically in all data center, right, where the system administrator, probably thousands of away from the data center, right? Because we manage the data center in Singapore, Ireland, all those things, right? So someone is sitting probably someplace here who's managing. So what it has done is there is multiple switches in a rack, right? You have a torch switch or a spine switches, and then we go to the torch switch, for example, and then torch switch then go talk to the management port, and then management port talks to individual nodes or individual servers, right? So we need to give that kind of access, definitely, because to be honest, data center typically is not accessed by people. It's very secure location.
Right. Yeah. So, well, I was sort of the root of all of this. I was thinking that a DCSCM module somewhere would be our ultimate route, and that would patch into this grid of modules.
Let's see you also. Yeah, I think I'm not sure about how but yeah, I think I see your point. You can have DCSCM too.
Yeah, so whether we actually create maybe a dedicated DCSCM module in the standard HPCM format, or whether it's just a remote unit that's cabled into the control plane network. So the physical instantiation, we should think about that for sure, and we ought to get that in the proposal for sure. Yeah.
Yeah, I think the DCSCM. So there's a, well, standard DCSCM has limitations. It's 1-to-1 ratio because it's just one processing module to one BMC module. In this case, you have like multiple processing modules connecting to the
Yeah,
BMC.
yeah. My assumption is you have one DCSCM that manages the entire network, and then you've got all of these BMCs that are local to each of that can do some level of security negotiation with the, you want one root of trust, right? You everyone goes back to one root of trust, I presume. They don't. And again, I'm not a security guy, so I don't know.
If you have like, if you look at in a scenario that if I place this in the, in some Amazon data center, right? For example, there is people coming in and out, renting the spaces or renting these modules, right? So you need to have a local, root of trust because maybe one module is rented by the defense, one module is rented by someone else in the banking sectors or someone else in the finance sector. So you need to have that. Yeah, I think we need to think about this. I think it's just there's a lot of things that we need to understand. I'll send, I think we can definitely brainstorm on that. I do have some questions that I can send to the team.
Well, yeah, I mean, if we can maybe brainstorm it through the document, if you've got, getting this into the document, maybe with a bit more meat around the actual devices and some sort of block diagram in a bit more detail and explaining. So all of these aspects that you're talking about that we need to account for, I think we want to describe, and obviously. Yeah, I think it would be good for you to how do we fold in the DCSAM here, and I'm happy to work with you on this.
Sure.
But if we can do it through the document, and then at least we're pulling the details in the document together from a proposal perspective.
So what I'll do is I'll create some emails to the team, right? The issues that we need to resolve, at least what I see from this project, right?
Right.
And then at least 5-6 issues I see now, but obviously it can change, right? As we're moving forward. So I'll send the email and let's consider, let's just do some discussion on that, right? How we're going to solve it, and then definitely in the next meeting we can talk more details.
Okay, all right. The only other aspect of this as well is the clocking, and I had some. These are really old ideas I had on the clocking trees. Had a couple of options of how do we. So the clocking's quite complex because you've got to clock all of the modules, and how much do we want to synchronize or be, with neighboring modules. So the clock infrastructure, I think, is a big piece that we need to consider as well in the system management piece. Is how do we do all that? So that's the hardware. If we can get pen to paper there, that'd be great. Let me stop sharing. But on the software side, I think the main thing for me on the software side, and John, you and Alex were having a good conversation a few weeks back, was along the lines of turning on and actually discovering the modules and how they're interconnected before, so we want a separate power on. By the way, that needs to be in the hardware as well. The system management needs to power up first, and it needs to be able to discover, the network, what modules are all connected together, what devices are on them, what protocols they're talking through their various channels. So the hardware would need to have a register of this, I'm talking MV link over this interconnect, and another module says I'm talking PCIe. And if somebody puts a cable between the two, the system management goes, hang on a minute, you're incompatible, you're not going to talk, so I won't bother turning you on, I'll just report an error. Or if you've got something like Infinity Fabric that can also talk PCIe, the system management says train into compatibility mode. You're, Mr. AMD. Okay, you can't talk Infinity Fabric here. You have to talk in PCI because the end is PCI. So those sorts of features.
So I do think it's gonna, let's assume that, like, I'm just trying to understand this, right? Who do you think is gonna do the discovery? Is it CPU? Because typically in a server, right, you have CPU who initially.
Well, that's right. So I don't believe, in my mind, the CPU will either go away or will become part of every module. Every module will have like a FPGA accelerator and have its own little CPU in the corner of it. So it's just going to be a heterogeneous mix of processors, all peer processors is the way I see it, and any one of them could be the host. Or we, so either we go real crude and we just have a sort of a host jumper, say you are the one in control of the 10,000 modules, or we have something like the DCSCM or some dedicated module at the root. It is a one that really is the host of everybody in terms of coordinating everything.
So you're thinking that one module to be the host or master who will go basically initial all the bookkeeping and all those things in discovery, making sure this, all this.
Yeah, and again, I mean, in my mind, it could be a dedicated module. It could be we can actually design a dedicated DCSCM module with a ton of if it needs to be collect all the logging information and all the rest of it, or be doing all the telemetry. Because let's remember HPC. And that's the other thing is at the HPC level, they like lots of telemetry. Specifically, IBM was very good at doing it with theirs, where they would, you're logging lots of things because lots of things can go wrong, a node can go down and you've got to recover, etc. So maybe we have a dedicated management module, an HPCM that may have a few terabytes of dedicated memory on it, and it's just for the purpose of managing, doing the system management.
So do you have any initial thought about what is the ratio of the process, the management module versus the number of modules? Because at the end of the day, it's going to be limited by the BMC capability, right? So what do you think?
I mean, it can, this is where it could be any module, I guess, because they all have the same system management circuitry on board. Versus if we need a DCSCM anyway, could it be a DCSCM dedicated module or just a DCSCM implemented in the E3, like where basically it can be plugged into somebody's module, and that makes actually maybe that's a good idea. Maybe if we said we actually convert the current DCSCM into E3 format, mechanically at least. And then that, if you have a DCSCM plugged into your module, into one of the E3 sites, then that makes you the master, and you then work with that DCSCM E3 module, and you bring everybody else up.
Yeah, I think the biggest challenge is that, so DCSCM has very limitation, right? Because it doesn't work it does work one-to-one module, right? And the moment you talk about a standard interface, the DCSCM interface, which is a limited number of pins, and when you're talking about 8 of these modules, you're talking huge number of signals that gonna.
Yeah, no. So that's where you misunderstand me. I'm saying that so the DCSCM at the pin level, at the mechanical electrical level, we do away with that way. We just take the features of the DCSCM being the root of trust, and we format it into the E3.S communication style, and then it gets connected to everybody else through the control plane that we have between the modules. So we don't need all of these horrible old-fashioned sideband signals that like they have on the current DCSCM. This is an important point, Manira. You're absolutely right, and so let's we do need to pull the thread. So get the email discussion
Yeah,
going.
let me send some emails. Just you know, I think this is the this is the difficult problem to solve, but
Yeah.
we'll figure it out. But yeah, let me initiate this discussion, and then we'll take the feedback from the community and see how we can proceed.
But on the back to the software side, we do need. So I guess, John, in terms of you educated Alex on some of the high level system management features that have been added in Redfish and the likes, if I remember rightly. Do you think there's additional management that's needed, or do you think that would cover the basis of what I've been saying we would potentially need here for this discovery of the network and compatibility of protocols across links, etc.?
Well, that's driven by whatever use case you have for this platform. So Redfish, right, is a interface definition.
Right.
It is not an implementation, right? So you go to either open it BMC. If it's firmware, you go to a software agent if it runs on top of the OS, and those are the implementations you need to look at.
Right.
So all because it's in the API definition, it may or may not imply that people have actually implemented it. And so that's driven by whatever the use case is for that management domain.
So,
Right.
John, if you look at the Redfish, right, I'm just a little bit confused. Definitely, Redfish, you know, I can see there's an IPMI, the management pass that you can try that, but there's a lot more other functions at BMC that you cannot start with the Redfish. And in my mind, you know, Alex, I think, Alan, sorry, Alan, can you just look into the Open BMC for that?
Sorry, reshare the diagram.
Right, Alan? I'm sorry, what?
Say that again. What did you want me to do?
No, I think, can you just look into Open BMC for the software? And the Redfish is part of this Open BMC as well, right? Because this is just an IPMI tool that they're redesigning, which is not the full functionality of the BMC. You still need other functions of the BMC. So my suggestion is that
Let's get clarification of the naming once again. Okay, Redfish is an interface definition, the RESTful definition, which can be implemented in many ways. OpenBMC is one of those implementations. It doesn't implement all of Redfish, and it exposes the Redfish interface. In addition, I used to expose the IPMI interface. That's all it is. So yes, you can decide to use the OpenBMC. You can decide to write your own firmware. Doesn't matter.
Okay. And I think we should be based on OpenBMC. That's what OCP is doing, and that's what everyone seems to be.
There's already a lot of things developed on OpenBMC platform, right? So I think for simplicity, my proposal is like, hey, look at the OpenBMC, because that's, you know, most of the codes are already there.
No, I completely agree with that. It's what we need to build on top of that that's missing for managing a very flexible, incomposable, modular architecture. That's my and I thought that John, you and Alex were discussing, or Alex was saying that higher level management aspects in you. It seemed like you pointed to him in the right direction to say yes, there was already hooks in place to support that.
Hooks means that the Redfish model already comprehends the resources and interaction necessary to compose a system. So we defined it in interface, right? Now, whether there's any implementation which actually implements that model is a secondary question. So you look at OpenBMC. OpenBMC has not implemented the composability model. right? You'll get telemetry, you'll get other firmware update, but you're not going to get composability. You need something much higher, like a rack manager, to say, oh, I want to expose composability. I can go implement this redfish model, right? I can use that as the interface, and I just have to implement the resources below that model.
Okay, so all right, so maybe we need to be looking into rack manager software, or maybe just start again, because we're so different.
Right. Again, you need to say to do management of your system, these are the types of management tasks you need to go do, right? And then say, okay, first question is, has Redfish defined the interface, right?
Right. Okay.
And then if it says, oh, it's been defined, great. Now let's go find out who actually implemented this thing.
Yeah.
Right. Then you'll get to a implementation that you can start with.
Okay, so it's a bit of a detective work to begin with to find out does it exist in Redfish is a definition of standard, and then has anybody implemented it, and then how have they implemented it, and how applicable is their implementation to what we need? And so could we start from what they've done, or do we need to start from scratch?
Oh, it depends on whether that implementation is open source. So I know there have been implementations of the composability interface support at the low level, but the rack manager portion is proprietary. Okay, so that's why within the OCP hardware management project, there is a project called Open RMC DM, which is the Open Rack Manager, and they've implemented the telemetry interface and the aggregation interface of how you, within a large group of things, create subgroups, and then either firmware update the subgroup, right? Or so you can take a much larger system and say, you know, I want to upgrade to, I want to find all the systems which are in firmware 1.1. I want to upgrade them all to 1.2, right? But I don't want to impact everybody else. So you go create a subset and you operate on a impromptu collection. So if someone were to walk in and say, hey, this is a nice code base because it's got Redfish on a northbound and it's got Redfish on a southbound to manage OCP nodes, that we need composability here. And then you have a base from which to add composability code to go implement composability.
Okay. So basically, Open RMC DM, you said. Is that what the CMS group are working with?
No. Nope. We'll bring them online. We're directing the GPU guys who have GPU firmware update for GPUs to it, because guess what? Redfish has a firmware update interface, and it's been implemented in Open RMC DM. So,
Okay.
So right now it's written in Golang, and it's in the OCP GitHub repository.
Yeah, I think this is a very good point. I think, what we need to do, I think, instead of going to this thing, I think we should define what we are looking for. Mm-hmm. And then we can shop around what is that option that we can go, right? I think to start with the functionality you are looking for in planning.
Yeah. Before you go to Amazon, you better know what you're buying.
Right. So John, is what you've just said is helped an awful lot just at the basic level. If you got a good handle on what I'm saying is, I don't know what's there and I don't know what's missing, right? It sounds like you have a very good handle on exactly what's there, exactly what's missing, and well, not necessarily exactly what's missing, but what exists out there.
I can tell you very well what exists, right?
Yeah, and
what I don't have is
I'm
not a subject matter expert on HPCs. So I need the HPC view of what you guys need for manageability, and I can say, hey, it looks exactly what PC guys want, except for these XYZ things, and so we need to go figure out if that's been.
What
Is could you write a few paragraphs in the proposal as to where we are at in what you've just described in this last few minutes? Could you put that down in terms of this is the framework that exists in the data center land? This is these are the proprietary bits, or this is the open bits, and then what we can do is if we can get a little bit more clarity around that and on paper, then we can between us with Alex hopefully as well, we can start to say, well, okay, these are the gaps that we need to fill, that this effort, hopefully funded by the DOE, will give us the open source code pieces that we need so that the system management of an HPC machine could be consistent going forwards rather than reinvented with every new machine as it is today. Like, does that make sense?
Yes, it does. I'm just looking at my time frame, what other things I need to go do. And writing a proposal, a project proposal, I don't know if I can go do that.
Yeah, I'm not necessarily going to write the entire proposal. I'm thinking that could you outline where we're at? What you just said, in a few paragraphs in the proposal, because I think the proposal, we want to set the scene as to this is where we're at and this is what we need to do. But if you could help get on paper what you just said, basically this is where we're at, then maybe Alex can help out, and and we can work with him as well, Munir and myself and Mitch and everyone else, is to say this is what we need once we understand what we've got, if you see what I mean. So if you could put the words down that just explain where we're at.
Once this proposal, let's say, is accepted, right, then how is this money going to flow?
So the way I was expecting the money to flow was people that contribute to the proposal and say, this is what needs to be done, and we're prepared to do it. That it's so everyone's going to need to say, like this piece I'm asking you to describe doesn't commit you to do anything if you don't want to.
No,
if you think you can help out, then all I really wanted your words in the proposal was to really get the rest of us on page as to what is out there already that we don't have to get money to do, and we only have to get money to do the stuff that's missing.
Okay, so I can provide you all the presentations and collateral necessary. You guys can put whatever you guys want in the proposal.
Yeah, no, I guess it was just a brief description of literally what you just said.
Right. So I will give it to you in a Word document or PowerPoint. Or
okay,
whatever.
all right.
You guys can stick it. You guys can stick it in the proposal.
Okay, fair enough.
Because I need authorization from Intel to do anything.
All right. Okay. Yeah. All right. No, that would be great. Yeah, it's just it would be just great to get that little starting point where the rest of us can, at least you've got little pointers in the paragraphs and you're explaining this is done here, here, and then it allows the rest of us to begin to get a better picture of exactly the lay of the land right now, in what's missing and what we need to do.
Right.
And hopefully Alex is already on that path based on your productive conversation from the last one. So yeah, that would be great if you can do that. So, but yeah, in terms of if we get the proposal funded, my intention is that anybody that wants to contribute will contribute to the proposal. They will say what work needs to be done. They will say this is how much money we need to do this piece of work, and we'll roll all the numbers up and put the proposal into the government. And if we have a top-level system integrator, they might get the big check and they'll roll the money down to the people doing the work. Okay, guys. Well, that covers both of the topics at the level.
Just a side topic, Alan. I think we discussed about the I think in the OCP, I don't remember the name, but there's a guy from Los Alamos lab who was in looking at our BMC for about an hour, showing all the BMC functionality. I'll give you the name if that helps.
Okay. Okay. All right. Well, thanks, guys. Much appreciated. And Munir, should I give you access to? I'll give you access to the proposal so you can get it. All right. I think that's good for today. Thanks very much.
Thank you, guys.
Bye.